Now that we have the infrastructure of our vSphere cluster set up, we're going to take a bit of a closer look at virtual machines and something called vApps. vApps is something that allows us to group a set of machines together that form part of a particular application. So that might be you have a front end, an app server, and a database server, or multiple database servers, for example, and you want to group them together logically so you can manage them as an app. First of all, let's take a closer look at some of the settings on our Windows 10 VM. We already took a quick look at this when we configured this VM during the Getting Started module, but again we have the number of CPUs, how many cores per socket. We have CPU hot add, which again allows us to add virtual processors to this virtual machine as it has been started. I'll remind you at this point, CPU hot add can have an impact on NUMA, non-uniform memory access, which is beyond the scope of vSphere Foundation. However, understand that enabling CPU hot add can cause a performance impact, so you should only enable it if you actually need it. Also, CPU hot add is not included in the vSphere Essentials licenses. It will let you turn it on, but if you then try to use it at a later date, it won't let you do it. So there's no point in turning it on if you're using vSphere Essentials. You can reserve or limit the amount of CPU that this processor, this virtual machine's processors can use, and you can define shares. So in vSphere, each virtual machine is given a number of shares based on how much CPU or RAM, etc. it has. So this has 2 CPUs, so it has 2,000 shares. Now that 2,000 doesn't mean anything on its own, but it is relative. So if I reduce that to low, it's now 1,000, so it will have a lower priority than another virtual machine with 2 CPUs, which will have a default of 2,000 shares. If that was 200, if we set all of our virtual machines to use 200 as the base, again, there will be no priority. You can set custom values, but it does tend to upset the balance of resources in vSphere. If I suddenly set that to 40,000, it tends to cause a few issues. And you may well come across a question on the exam, or maybe when you get to the professional level exam, that shows a virtual machine that is underperforming, shows the configuration page, and shows that someone has added a 0 to give this particular VM priority, and it's causing huge performance issues for the other virtual machines. So generally speaking, you're going to want to stick to low, medium, high. Hardware virtualization, so we talked about this when we built the ESX hosts, of course. So if you're wanting to run a hypervisor within a VM, then you can do so there. As I've said before, it's not supported for production use, certainly not recommended. So it's useful for labs and for testing, but you won't want to do this for a live environment. Enable virtualized CPU performance counters. Enables the hypervisor to pass through certain model-specific registers from the CPU to the VM. This can be used by software developers to optimize and debug software based on more detailed information provided by the CPU, which would normally be obfuscated by the hypervisor. The IOMMU is a little bit similar to the hardware-assisted virtualization, but it extends the memory management unit to the guest OS. Under memory, again, very similar settings. We can set a reservation, we can set a limit. Bear in mind, we have 8 GB in there assigned to the VM, but we could set a limit of 6 GB. So at that point, we're saying that this virtual machine cannot use more than 6 GB of the physical RAM in the host. Anything beyond the 6 GB, it's going to have to use the swap file, which could hurt performance. Generally speaking though, you're going to want to use the shares value to manage the allocation of memory. And so we can see the shares value there is 81920, gets 10 shares for every megabyte of memory. This host has 8 gigabytes, that's 8,192 megabytes, which gives it 81,920 shares. So you see those shares values again are proportional to how much resource we have allocated to the virtual machine. On the hard drive we can see that it's thin provisioned. Sharing is where we share a virtual hard drive between multiple virtual machines, which is useful if you're doing something like Microsoft cluster services or Windows failover clustering as it's now known. There are a number of requirements to support that sharing, to support Windows failover clustering in virtual machines, and that is beyond the scope of the vSphere Foundation exam. If you do want to deploy a Windows failover cluster or a similar technology that uses shared disks between multiple VMs, you need to get onto the VMware knowledge base and take a look at the requirements for doing so. The VM storage policy is not in the scope of the vSphere Foundation's exam. However, essentially it allows you to create policies to say, for example, this particular disk should be stored on an SSD or should be moved to an archive tier. And you can set that policy there, and it will automatically move the machine between data stores to meet those requirements. As I say, it's not in the vSphere Foundation exam, so we're not going to go into too much detail here. Exactly the same again, the shares. Each disk will generally have 1,000 shares. You can increase that to high, drop it down to low, or set a custom value. Again, try to stick to the low, normal, high values. When you start creating custom shares values, that's when you can start to find you've introduced a peculiar balance issue. Limit IOPS. You can limit the number of input-output operations per second, or IOPS, that this particular virtual disk will generate to the SAN. Now I should add this feature and the shares feature there is dependent upon a vSphere license feature called Storage I/O Control, which is only included in the Enterprise Plus license. If you don't have Enterprise Plus, you won't be able to set that value, unfortunately. SCSI controller, what sort of SCSI controller are we actually presenting to the virtual machine? So this, when you create your virtual machine and you specify the operating system that you are using, this is one of the things that vSphere will set for you automatically based on that for the best compatibility with that operating system. You're not going to want to change that often. You may want to change it to the VMware ParaVirtual driver once you've installed the VMware tools. That is rather than emulating, in this case, an LSI Logic SAS controller, the VMware ParaVirtualized SCSI controller is a VMware specific controller. It's not trying to emulate anything, it is optimized for vSphere environments. But generally speaking, you should be absolutely fine to leave that as is. Network adapter, so we can choose which network we're on. We can move this to a different virtual machine port group live. If I had another virtual machine port group deployed there at the moment, I could change that. Connect at power on. Be careful with that setting. If you untick that and then reboot your virtual machine, or the virtual machine reboots for Windows updates, for example, you will suddenly find it's not connected to the network anymore. Adapter type, exactly the same as the SCSI controller. By default, we emulate an Intel E1000E network adapter. Again, that was set automatically by vSphere when we specified that this was a Windows 10 64-bit virtual machine, but you can change that to a few other types if you need to. MAC address. VMware have their own MAC OUI. So if you're not familiar with the OUI system, the MAC address is the first 6 digits, so from 005056, a vendor organizationally unique identifier. So 005056 is VMware's own OUI. Broadcom have another set of OUIs, and then the vendor sets everything after the colon. VMware uses their allocated OUI and then generates the rest of the MAC address using an algorithm. It's rare you're going to want to change that, but you can do so there. At the moment, it's grayed out because the virtual machine is running. And we can disconnect the network cable there. So you untick that, the operating system running inside the VM will behave as if you had unplugged the network cable from a normal computer. CD drive. Now this is an important one that often gets overlooked. There is a CD drive added by default to most of the VMs that you create. By default, that CD drive is connected to the virtual SATA controller that gets presented to the virtual machine. You can specify which of its virtual ports you want. You're never going to want to change that, to be honest. But the device mode, you might. Emulate CD-ROM will do just that. It's an emulation mode. Pass-through CD-ROM is useful for when you want to mount the virtual CD drive in your virtual machine to the CD drive that is on your PC. So you open the vSphere remote console and you attach the CD drive in the VM to the CD drive in your client computer. So this is for administrative purposes only, not for going in through RDP or something like that. If you select Emulate CD-ROM, it will just present an ordinary CD drive to the virtual machine. There will be no additional functionality, which means you won't be able to use a CD writer. So if you've got something in that VM, you need to write it to a CD, to a physical CD, and you can't just retrieve the file over the network. You can go into the vSphere remote console and mount your local CD drive to the virtual machine, but it must be in pass-through CD-ROM. Otherwise, the virtual machine will not acknowledge it as a CD writer. You may or may not have a USB controller attached by default. That depends upon the operating system that you selected, of course, when you created the virtual machine in the first place. For this Windows 10 64-bit, it has created a virtual USB 3.1 controller. That means I can plug a USB device into my computer, I can go into the vSphere remote console, and I can mount the USB device on my PC to that virtual machine. Can be handy if I need to upload some files directly into the virtual machine without going through the network. You can also plug a USB device directly into the host and mount it that way. And that's when DRS rules can come in. You might need to then create a DRS VM to host group rule to make sure that that virtual machine is always on the host where you have plugged in that USB device. If you do have virtual machines that use USB devices, it's well worth thinking about how you're going to do that and whether there are ways around it, because there's not really a lot of point in HA if you've got a mission critical VM that is reliant on a USB device that is plugged into a server in your data center. There are network USB servers available, although they're less common these days. If you can get around that dependence upon a USB device, I would do. It's handy for short-term requirements. You know, you've just received a hard drive with 4 terabytes worth of data, and instead of copying it over the network, you want to load it directly into the VM. Yes, plug it into the host and mount the USB hard drive to the guest VM. Video card generally handles itself. If you do have something like the NVIDIA Grid GPUs in your hosts, then you may well want to come in here and tick enable 3D support for those VMs that need to use it. That NVIDIA Grid GPUs and virtual 3D graphics is not really in the scope for the vSphere exam. Just remember that that's where that setting is. There's that virtual SATA controller I mentioned earlier for the CD drive, and then additional hardware. There's a chunk there of hardware that is generally connected to most virtual machines that you don't really interact with in any way whatsoever.